actually.
The common
So,
link. Yeah.
and the topic is very important. Important in that sense that financial inclusion, and I mean all my work related to my PhD, and as a part of Bandhan Bank, as a Bandhan Board of Director in that Bandhan Financial Holding Limited and Northeastern Financial Inclusion Trust. uh, Even from the microfinance now gradually shifted to financial inclusion. So this topic is very, very important, and this is a tool for poverty alleviation and handling so many issues. If we consider about the gender, also for the women empowerment and gender equality, the financial inclusion, and almost all the our formal banks, even NABARD also, they are all working on the financial inclusion, Reserve Bank, and so it's a very wonderful topic. I am sure that is going to be, and equally, it is also will be wonderful when you are taking the session. I think so. Welcome to this session, and this is the last day of our 1 month journey on artificial intelligence for rural development. But financial inclusion, and this is very important how we can go ahead with that. And with this, once again, I will the participants are joining, so that's why we are waiting for a few minutes. And now slowly they are reaching to us, and I'm sure equally it will be a very wonderful session, and all the participants will enjoy this. And if they have any question, they can ask for that after your presentation, and it will be good session. With this, because your profile already we have shared to all the participants, and with this, once again, welcome to you for this session. Thank you very much.
Thank you, Professor. Uh, so, my topic today is AI in healthcare. So, that is why I asked about, since it is AI related topic. It goes with the theme also, but not directly related to financial application and women empowerment. I saw that will come from the next talk. The next presenter would be talking
Yes,
on.
yes. She'll take from Turkey. Yes, she'll do
Yes,
it.
my presentation is on AI in rural healthcare. So that is why I asked about the participants. How many of you not computer science background? I saw a few of them. So I will try to keep it more generic so that it would be understandable to even computer science students and non-computer science students. So let us start. At any stage, if you find a difficulty of understanding what I'm trying to convey, you can make me stop and explain it in details. Okay. So I will rather enjoy it to be an interactive session. So don't feel shy to stop me and ask for details. So I'm starting now. Please let me know if my slide is visible.
Yes,
Yes,
sir,
it
it's
is.
visible. Yes.
And
Yes, it
Yeah,
is.
but the
yes,
main screen.
and let me know if this is changing. It is changing.
It's still in the slide, not in the PowerPoint
The slide is
slide
not
yet.
changing.
Not yet.
Okay, so I can do it this way. You can see the change in slides here.
Yes, sir.
Yes, but it's not in the form
Yeah,
of
it's changing now.
full.
Full screen is not changing. That I am
Yes.
wondering. Okay, just a minute. Let me run it. Is it changing?
No,
No.
sir.
No, but I think
No,
we can use it like that. since
Okay.
we can see the content.
Yes, yes, yes. So I will go this for view only. Okay. So, okay. Once again, good evening and good afternoon, whatever is applicable to you. I'm Dr. Sholik Sengupta from India, Kolkata, Ali University. One of my colleagues has already spoken to you, Dr. Abhishek. This is my mail ID. If you want and interested, you can reach me at ssc@earlier.ac.in. So the topic that we are going to cover today, I was supposed to have a topic on 1 hour, so I crafted this way. I'll start with the what is the importance of AI in rural healthcare, then what is Internet of Medical Things, and then why distributed system and big data architecture are important in rural healthcare, and how medical image analysis with deep learning uh, can be employed in rural healthcare, and finally what is federated learning and how this is important from the perspective of AI in healthcare. So these are most of these are technical topic. So I will, if you want, I can go in details. But if you are not able to understand at any stage, you can stop me. I can explain it more genetic quickly. So let us start. Since I'm from India, I have this data only from the Indian rural health statistics. I start with this context. So why AI in rural health is so much important? So in the right hand side, you can see the pyramid structure uh, of rural healthcare in India. More or less, this would be same from your country, especially in South Asian countries. Uh, in India, at village level, we have community-based healthcare providers. Uh, Around 1,000 people they can serve. Then top of that, we have sub centers or health centers that covers up to 5 to 6 villages. Then we have for 30 to 40 villages, we have one primary health center. And that is the first time you will have a one or two medical officer and three staffs. Top of the primary health care centers, we have community health care centers, CHC. This covers around 100,000 population and 100 village. And finally, on top of all this CHC, we have district hospital and specialty hospitals, where first time you will get the ambulance service. So this is the actual hierarchy of healthcare center in India. And from the government of India statistics, you see the left hand side, you will see that around 36% of the population are covered with CHCs and 30% covered on primary health centers. And interestingly, uh, as per government record, more than 10% people don't receive any treatment. After so many years of Indian advancement in technology, we are still unable to cover up more than 10%. That is the government of India record. In actual reality, it is more than that. So another, yes,
Maximize your video picture, sir. Maximize.
maximize means you can see this,
Yeah, it's okay,
but
but it's in full scale, sir. And no need for that slides over behind on that.
no, if I
Yeah, if it is bigger,
That should. Oh,
yeah,
hold on.
okay. Ah, yes, now clear, sir.
Now we are seeing full screen,
Yeah, it's full screen now. Thank
and
you,
the
sir.
Yes, sir. Yes.
slides are
Yeah,
changing also.
yeah, it's
Yes.
okay, sir.
Yes,
Thank you.
yes, yes. Thank you, thank you. Just
Okay,
Okay.
click
okay,
the
Yeah.
hide button there. The hide in the
okay,
on the screen.
okay, okay. You see.
Yes, thank you so much.
So this is what the statistics is all about. The government, according to Government of India record, uh, uh, just now, if you have missed my presentation slide, I have talked about the hierarchy of the health centers in India, and more than 10% people, the Government of India is unable to serve, to provide any service as per their record. So this is a big concern now. And this is another healthcare data on 2021 data, it is, where we identified what are the deficiencies, and it is found that infrastructure has the largest deficiency of 44%, human resource like medical staff, doctors, trained nurses, this deficiency is around 36%, uh, medicine around 15%, connectivity around 3%. Connectivity means even if the uh, healthcare center exists, and even if there is staff and medicine available, it is located in such a distance that the people of the villages cannot afford to take service. So that is the connectivity issue. And quality of service issue is that everything is available, but the service is unsatisfactory. So that covers 2%. So main drawback you see here is the infrastructure and the staff. It covers up to 80% of the deficiency. Sorry. So how AI can take a role in this? Now, infrastructural deficiency, you mean that we do not have health centers actually created to serve people, and 36% time we have created the buildings and infrastructure, but we do not have adequate staff. We haven't sent any medical officer or trained nurse to serve the people. So these two, if we can cover to some extent by technology. So initially, it started with telemedicine. That is the first technology. After the proliferation of internet, the telemedicine during the COVID time, most of the countries have implemented telemedicine, where using video conferencing, uh, the doctor can directly connect to the patient, and patient can show their symptoms or even reports shared on screen, and the doctors then advise accordingly. But saying that, this requires at least one computer or mobile phone where you can take picture and upload your description and reports. So that is not possible in actual a poor country like India, where the rural people don't have that luxury and then don't have the necessary education to connect in Google Meet like anything, and uh, upload the reports to the doctor. So that is actually not that useful in remote places. So what could be done with AI? So apart from telemedicine, what AI can do is AI can automate the process. It cannot replace the existing decision making by expert doctors or practitioners, but it can give you the initial impression what is going wrong. When there is a threat, there is a potential threat to the patient, that you should go to the uh, nearest hospital or health center to visit a doctor. So that surveillance and monitoring can be done using AI, and thanks to the advancement of Internet of Things. So what type of, so if we can do this, we can cover these two parts. So we cannot replace the medical staff, but we can assist the decision making process of human medical staffs with the AI based predictions. Similarly, infrastructure is required, but the initial phase, whether there is a risk or not, if that can be treated from the home of the patient itself, that would be of great help. So these two aspects we try to cover with AI. These are some application of AI across the world where in advanced countries, people are using it for uh, accurate diagnosis, disease prediction, and virtual health assistant, treatment of rare disease, and this part, electronic health records. In advanced countries like in Europe and America, it is almost 99% of the people have a centralized healthcare record. So whatever your history of disease or tendency of in a particular disease you have, that is already recorded. So even if in case of emergency, uh, the doctor can understand what is your history and what could have happened to you and the type of emergency. In country like India and Southeast Asia, we don't have that privilege yet. So in only after COVID in last 4 or 5 years, uh, the government hospitals are trying to keep track of the HR, but again, this is in very infant stage. We don't maintain proper electronic health records here. Uh, Identify verification is where the healthcare is free and government need to understand who is taking this privilege. These two part, automatic image diagnosis, because most of the critical illness, uh, we go through medical test of imaging like X-ray, CT scan, MRI scan, ultrasound. This all type of imaging we do at our local centers, local healthcare centers. But the initial impression, the what is wrong, we ask often the one who is doing the X-ray or the radiologist, is everything okay or is there anything? And 99% of the time, he or she will say that I am not a right person to comment on this. You visit the doctor, only the doctor can assure you that everything is okay. So now for the rural area, the problem is that there is a high scarcity of doctors. So it will take say 1 month to you have a chance to talk with the doctor to show you to show your report. So what AI can do is AI can give you an initial impression that is there everything okay or is there any abnormality there in your report, so that you can understand the seriousness. So even if one doctor is unavailable, you can visit another doctor. So you can save time and a crucial time for your health benefit. So these are the aspects that AI can help in healthcare. Talking about AI, this is a buzzword these days. What is artificial intelligence? And what is data science? What is machine learning? What is deep learning? And what is generative AI? So, how many of you have heard all these things like in data analytics or data science, then AI, then machine learning, deep learning, and last one is generative AI? Can tell me?
Yes, we have in our organization we have such a data ICT expert, but
Okay. So you have heard about this, but you don't have any clear-cut concept of what separates data science from AI and what is machine learning, how it is different from machine learning, isn't it? So let me clarify this first. So data analytics is that data is everywhere these days. Everything is producing data. Whatever we are doing on internet, whatever we are doing in test, in medical test, our digital imaging, Whatever forms we are filling, everything is creating data, and the data is everywhere. So any tool that can analyze the data to find any meaningful information can be considered as data analytics. So this is the larger umbrella. Inside that, we have artificial intelligence. So what these there apart from artificial intelligence in data science, it is statistics, plain statistics, Excel tools that you can use for data analysis, visualization, that doesn't fall under artificial intelligence. So what is artificial intelligence? Among the data science tools, one that mimics human behavior of intelligence is known as artificial intelligence. Whenever there is a non-deterministic way of understanding anything, if a computer system can mimic that part of human behavior, it is known as artificial intelligence tool. Now there are different type of artificial intelligence tool, like non-deterministic approach, or heuristic approach, soft computing, biology inspired computing. These are all fall under artificial intelligence. There is a subcategory of artificial intelligence which is known as machine learning. Now, machine learning is something where we don't understand the logic. For example, we don't understand the logic how we can identify whether a image is of a male or a female. There is no deterministic rule. If I give you a picture of one person, you can instantly identify this person is a male or this person is a female. How we can understand? If I ask you, can you explain how you are doing this? Like, is there any rule that if eye size is that bigger, it is female? If nose size is that large, it is male? And if the texture is that amount, then only it is male. Apart from beard and mustache, if it is clean shaped, we cannot give a logic that why this is, but we can instantly do this. We don't have the logic, but we can instantly do this because from the childhood, our brain or the neurons of our brain are trained in such a way that seeing example again and again and again, we don't think. We don't think which is a cat and which is a dog. Instantly we can decide. But if I ask you why you are so sure, can you give me the measurements that you are following to identify whether it is a cat or a dog? It will be problematic. But we don't think actually. We can do it instantly. Can artificial intelligence mimic that nature? Luckily, so. We have a neural network system where artificial neural network, where we can present thousands of millions of samples where we know the answer that this is image of a cat and this is image of a dog. We show it again and again and again to the system, and system can adjust somehow the weight of the matrices so that we say it has learned to distinguish between cat and dog. This is known as a type of algorithm known as supervised algorithm of machine learning, where we present the data and the label itself. There is another category of machine learning which is known as unsupervised, where we don't give the label. Label means given an image, whether the tumor is benign or malignant. This we know beforehand, and then we show it to the system and ask the system to learn this type of image is known as benign, this type of image is known as malignant. Another type is this is supervised. Another type is unsupervised. What is unsupervised? Like given a set of data, we find out the similarity between that data. We don't know what is the similarity. Is there any similarity? At the beginning stage of, say, COVID, when people didn't understand what are the common symptoms of COVID. So where patients have come with symptoms, we can ask the system to identify what is the common thing, what is the common pattern among these patients. Then we identified, okay, there is a cough, there is a lung infection, and there is a high fever, and there is some people have diarrhea. So these are the common symptoms. So there is a pattern identified for COVID. This we can do also in machine learning, but this is a separate category known as unsupervised. Then comes a subtype of machine learning known as deep learning. Deep learning is where we use neural network, and the layer of neural network is so large that we call it the deep neural network. And the operation we perform are mainly convolution operation on the images to extract the features of the images, and then we propagate through the deep neural network to find out the decision. This is a special type of machine learning. Apart from deep learning, what else there is machine learning? There are conventional algorithms like support vector machine, logistic regression, decision tree. These are conventional machine learning algorithms. But deep learning is a special type of machine learning algorithm. I will show you in details what is the state of the art of the deep learning. And in very recent, you may have heard about transformer-based model. This is known as generative AI. So generative AI is a sub-branch of deep learning where the model has learned to generate. Deep learning model has learned to classify whether this cell is benign or malignant. That is classification. But generative AI can generate anything. It can generate image. The fake images these days people are generating, and the text, particularly in natural language processing, there is a lot of development using generative intelligence. We are all using this chat GPT and DeepSeek. These are the example of generative intelligence where the AI model can generate itself. So what is the context of rural healthcare with generative model? That is the chatbot I show you, the chatbot that generates answers. So even we can generate, even if we can generate the chatbots for medical system that are trained over long archived medical records, so that it is expert to suggest you the preliminary things in your own language. Uh, even in 2020 in India, in state like West Bengal where I reside, still I have heard news that people have died out of diarrhea. I know personally one person. So that lady has died of diarrhea with a simple ignorance that a salt water frequently taken 5 times, 10 times a day could have saved her life. So even in 2020, you can imagine that this information, none of the family members of her uh, knew that. So even salt water could have saved her life. That was not given. So this ignorance we can counter with chatbot designed in local languages. So these days, smart people say, okay, Google, Siri, they can ask, but that is required in English language proficiency if you want to fetch some information. But these days,
Hello?
yes,
Hello?
yes.
Oh, I'm not hearing any sound.
Where's this? Am I audible to all others?
Yes, sir.
Yes, sir.
Okay, then I
Can
can.
hear you.
Okay, so a chatbot, like I told you, this type of chatbot here. So this type of chatbots built in local language could have saved life. Fine. Next thing we'll cover is the building block of rural healthcare in AI, known as IoMT, Internet of Medical Things. These days, we have a lot of smart wearable devices that we can put in the body of the patient, and we can remotely monitor the health condition of the patient. So this is a paradigm shift in digitizing the healthcare. Many of us are aware of at least one or two of these type of sensors, like pulse oximeter, PPP, and then ECG sensors, then continuous glucose monitoring sensors. These sensors are very cheap and easily available. So it can be placed on the body of the patient, and there are three layers. One is the device layer. The device work on very small voltage power supply. Even a 2 to 3 volt battery or 5-volt battery can operate these devices. We all have at least once used pulse oximeter. Post COVID, it is very common. So we can see that pulse oximeter can measure the oxygen saturation level with a very teeny device that operate from 2 volt to 3 volt. So it is very handy. And blood pressure monitors and heart rate, pulse rate. There are ECG sensors. If required, we can very low power ECG sensors are these days available. Like wearing a cap, you have a terminal ill patient on stroke or any other neuro disease. You can place it like a cap in the head, and you can control it remotely. You can check the signal flowing through. So we, in the left hand side of your screen, you can see that there are three layers. This is known as a decentralized architecture of remote healthcare in patient, where at the bottom layer, we have the patient device layer, where the actual physical sensors are attached with the patient to collect information, like blood pressure sensor, like oximeter, like ECG sensor. And these are connected to the edge computing layer. Edge computing layer could be a computer located some nearby location, or a gateway, or a base station that will collect all the information, aggregate it, and the third layer is it will send to a data center where you have facility for aggregating all this information from different edge computing devices, and where you can visualize the data. You can run the machine learning algorithm to identify the knowledge extracted from the data. So this part is the IoT or IOMT. You all know IoT is Internet of Things, and this day a special category of Internet of Things sensors known as Internet of Medical Things, which are wearable devices that we use. So the purpose is to collect information. Now, when you wear a smart watch, that stores information into the smartwatch itself. But when you connect the smartwatch to Wi-Fi, you can easily send this information very very easily to the nearest data center, where seeing the pattern of your pulse rate or blood oxygen level, a AI system without consulting a doctor, the initial impression whether your heart rate is abnormal when you were walking with a speed more than say 4 km or 5 km per hour, or you are walking through stairs, or you are doing any heavy lifting, you are going to market and carrying heavy bags, that times your pulse rate is going beyond say 120 and other consistent way. So if that periodic data a AI system can capture, so without consulting a healthcare profession, AI system itself can give you the first impression something is going wrong with your heart. So you can check. It can then you can implant another sensor which will collect your breath rate or your pressure maybe. So to confirm, so the edge device, the middleware, the edge device is responsible for collecting different type of sensors information in a packet, and that packet will be sent to the cloud. This one, the cloud layer, where at the data center, the cloud layer can analyze different type of sensory information coming from the same patient, and a machine learning algorithm can identify there is a hidden pattern or not. whether there is a probability that patient is suffering from a heart disease, which is very latent, which is not noticeable. The patient is not understanding it. So you see, many of the time people come late to the doctor and they are surprised to see that there is a heart problem existing for, because uh, in heart blockage it has found that 70 up to 70% blockage or 75% blockage, there is hardly any symptom. So whoever of us are attending this meeting, we cannot say that we don't have any blockage in our heart, because up to 70% blockage there is hardly any symptom. So how that can be traced? That can be traced if there is a continuous monitoring of our heart rate, of our breathing rate, of our oxygen level in our body when we are doing different type of activities, not sitting idle or lying down. When we are walking in a speed, when we are breaking the stairs, when we are cycling, when we are swimming, if the continuous record is fetched, and it can be done very easily, just wearing a band. That's all. So the band will collect all the information, and whenever you come to a place where you have Wi-Fi connection, it will be automatically connected and it will send the information back to the server. So without any effort from yourself, AI system can check before the doctor come whether there is any abnormality or not. That is the beauty of IoMT of Internet of Medical Things. These are the key applications of sensory data analysis. So you see where the data is coming from, mainly from the IoT devices. And since this periodic data that is being collected, the frequency could be like, say, 7 days, 2 weeks, 1 month. There is a huge amount of data created. So you need a proper architecture to handle this large amount of data. What you can do by analyzing this data? A chronic disease management. If you are in a remote place where it is problematic for you to attending the doctors frequently, but you know your conditions, like you have hypertension issue, you have diabetes, or you have heart disease that is known to you. So, but you cannot monitor yourself. So what you can do, you can take help of IoT devices, particularly wearable devices. These days, in future, implantable devices is also coming, but even wearable devices are good enough to check the chronic disease. Post-surgical care, we cannot occupy hospital stays long after a surgery, so you have to come back home. But that period is very essential. Whether you have a surgery, so next 7 days or 10 days, it is a critical period. Whether you are having infections in the surgery place or not. So simple scanning the operated area with a mobile phone can let you know whether you are having any infection or not, or the healing is in a good way. So that can be done using remote sensory data analysis. Elderly care is another issue. In many places, we have to leave our elderly parents at home, and there is nobody to take care. So CCTV camera is very handy, but intelligent CCTV camera is even more beautiful thing, where from the video of the CCTV camera, it can identify fall. The main problem of elderly people is they fall, and that causes problem. Whenever they fall, they can broke their bone, they can have head injuries, which is very crucial. So fall detection, there is a sensor that can detect sudden fall of human beings. So that alarm can be sent to the family member who is nearest to take care of that person. Adherence to medicine, if CCTV camera these days, if we can employ intelligent machine learning or deep learning algorithm, they can identify whether you have taken the medicine in correct way or not. Suppose you have to take a capsule 4 times per day, but you have taken it only 2 times. The CCTV camera will take that information and automatically analyze this person have missed doses of the medicine, of the crucial medicine, and the alarm will be sent to the nearest person. Particularly helpful with Alzheimer's patient. So elderly care at remote places is very big concern these days, which is being taken care by AI systems. Implantable devices. Many of the patients have pacemaker, uh, defibrillators, and neurotransmitters. They have implanted, but whether the device is working properly or not, that is a very crucial thing. But you cannot know whether the battery of your pacemaker is dying out. But if your pacemaker stops, you might have a fatal risk. So if that pacemaker is connected to the Wi-Fi, nearest Wi-Fi, it can easily taken care by the automated AI system, whether the pacemaker is going good or not. Same with neurotransmitters and defibrillators. Uh, but saying this, all these things are easier to say, but even we can implement this by the advent of electronic devices, but lot of issues are there. What are the important issues? First thing is that large volume of data. Large volume of data, the data that is being produced is so large that normal traditional databases cannot handle this large amount of data. So another thing is that these data are heterogeneous. Not all the data come from same type of devices. Different devices have their proprietary formatting of data. So you cannot just you suppose one PPP device or pulse oximeter device you are using, and next you have changed the device and bought in a new device, and that you are using now. But the data should be continuous. But since you have changed the device and the makers of the device are using different data formats, so it is very challenging to combine these two different heterogeneous data. And the large amount of data, knowingly unknowingly, you all are creating large amount of data, so that traditional data processing algorithm or database management system cannot handle. This is a big challenge. Number two is that real-time analysis. As I told you in the example of elderly people assistance, elderly assistance, real-time action is very important. Suppose a fault detection, you cannot do it say by surveillance of say video recording of 24 hours before. You cannot do that. Say you have to do it at runtime, at the real time. Whenever there is a problem or critical issue, somebody is choking, somebody has fallen, uh, the alarm should be gone immediately. So this real-time analysis is another challenge, because machine learning algorithm and all these deep learning algorithm, they work on archive data. That means the data are collected, formatted, stored in a proper way, and then machine have learned from that. But you don't have that time. Whatever decision the artificial intelligence system needs to make, it is required in real time. That is the challenge. Third challenge is the pattern recognition, and the fourth challenge is the personalized medicine. Pattern recognition means whenever a new disease has come, in India, we are these days hearing about a new disease called Guillain-Barré syndrome, GBS. But nobody knows what is the exact cause of this GBS. Some people are saying that it may be due to virus, it may be due to bacteria, and from where it is getting infected. Some people are saying no, it is not infected. It is not an infectious disease. Some people are saying yes, it is an infectious disease. This is coming from food and water, contaminated food and contaminated water. So nobody knows. So how we understand in this type of problem when first time arises, it takes many years to actually identify the root cause. Like it took say 100 years to people understand that malaria is causing by mosquito. So how do we can easily use artificial intelligence to find out? We can group the people who is having same symptom and what is the common pattern they are having. So if this information is extracted and by grouping or clustering the people of similar symptom, what is the common attributes they are having? So that common attribute may be diarrhea. So if that is diarrhea, so that new disease may have something with water or food. So this type of decision can be taken. Personalized medicine, these days this is very at its beginning stage. Uh, scientists are arguing that this chemical advanced medicines, uh, one size fit all approach is not correct. So we need to have personalized medicine. If our individual genome sequencing is known, and there is a probability that the protein-protein interaction uh, is not same for two person. So one medicine that may have a very good impact on person one may not have that good impact on person two on the same disease. This is because of the difference in genome sequencing. So this, but if you know, genome sequence is a very, very large data. Okay, so if you want to analyze the genome sequences to create your own personalized medicine, uh, you need AI assistance. So that is the future of AI in medicine, the personalized drug discovery. So these are the challenges. So for all the time I'm mentioning about very weak amount of large data, we already have a big data technology. I'm not going in details, but you may have heard these names. HDFS, which is Hadoop systems. MapReduce is a very known algorithm. These are some pioneer technologies for handling heterogeneous big data, Kafka, Apache Spark, and for real-time analysis, we have Flume. This is a technology that is used in big data for real-time analysis of data. What is known as a distributed system? A distributed system means we are separating the data from the logic and from the processing. So we collecting data from one end, the IoT sensors from the home of the patient. We are collecting the data. What type of data? It could be not only the health parameters, it could be the environmental parameters. What is the moisture level? Suppose you are monitoring a wound of the patient. So the temperature of the room, the moisture level in the room, the humidity of the room, uh, these environmental data are also important. So all these data are temporal data. That means time series data. It varies with time. The temperature of the room differs at every hour to hour. So this creates a large amount of data. So this data we store in, first we process at the edge layer, then we send it to the cloud layer, and using the big data analysis, using the cloud computing at big data analysis, we can process the data and we can consult with the doctors for healthcare record, users for sensory record. Like whenever there is a event of alert, the alert could be sent to the user itself. You are having this problem, you need to consult a doctor. If the data is archived, the doctor can see and consult with the patient. And for emergency situation, the big data analysis can fire event. It can fire an event. That event may directly call the ambulance for an emergency. All these things can be done automatically by the big data architecture. This is actually what happens in cloud computing. We have this left hand side, we have these sensors. you can consider this sensor to be placed at the patient's body, and the edge nodes are the nearest station. It could be the primary health center, it could be the community center that has a facility of storing and aggregating the data. A single computer is sufficient for collecting all this information. If you have a computer connected with a gateway, you can collect all this information, because this layer, edge layer, do not process the information, it just collect and aggregates. Then it send data across the cloud where the actual analysis part is done, and then the decision is automatically made. So far we have considered the data which are mainly numerical data. You see, the temperature data, the blood pressure data, the glucose data, the signal, ECG signal data. These are large in number because they are frequently extracted. Every minute, every hour, every day, these are collected continuously. So these are creating large data, but the good thing is that this data being numerical data, the aggregation is very easy. So it is only arithmetic operation, like we can average the blood pressure over 7 days. It is very easily done. You can aggregate the body temperature over 7 days. It is easily done. But next, the advanced thing that we will consider is you cannot aggregate on images. Suppose you have broken a bone and say 3 successive X-ray images has been taken of that bone. Now, whether the healing is appropriate, the bones are now joined or not, that you cannot say without visiting a doctor. But if you have an automated system, it is not like that your body temperature that is aggregated with simple arithmetic operation. You cannot aggregate these 3 images. No? So this part is more complex. Whenever we have images for medical record, images of medical record, we need deep learning, not conventional machine learning can do. So what are the applications here, particularly in rural healthcare? What are the applications that can be done? X-ray analysis. What type of X-ray analysis? Obviously for fracturing bones, or for lung X-ray, whether there is nodule in the lung which could be cancerous, whether there is a chest congestion due to COVID, pneumonia, or tuberculosis. This all you can actually for these are already established technologies. So at 98 and 99% accuracy, these days AI system can predict whether this is pneumonia, this is tuberculosis. In naked eye, it is very hard. Only expert can say that. Or supporting tissue samples are required for analysis to distinguish between which is COVID, which is pneumonia, and which is tuberculosis. But AI systems are creating 99% accuracy on detecting whether this is pneumonia or tuberculosis. Ultrasound images for breast cancer, for fetal health in pregnancy, and any internal abnormalities like whether your liver is enlarged, or you have a stone in kidney, or you have some problem with pancreas, or your appendix has expanded. These are easily done these days using ultrasound imaging, automatic analysis. Ophthalmology, your retina scan, whether there is a glaucoma or not, or you are diabetic. There is a disease called diabetic retinopathy, which is abnormality in retina. Exudates are formed and ultimately it leads to blindness. So that can be controlled. And dermatology, where you have a continuous skin disease like psoriasis or eczema, or even worse, you can have melanoma or skin cancer. That monitoring can be done. So there is lots of research paper available in last say 10 years, and already multiple systems are in function where this is available. Why I put this as others? Because What is the objective of this automatic analysis? I am assuming that there is a shortage of doctor. So with shortage of doctor, the X-ray can be done in the local health center. There is a X-ray machine and there is a, radiologist or any X-ray clinician who can take the X-ray images. But whether the abnormality is there or not, suppose the person is suffering from tuberculosis or pneumonia, if it takes a 1 month to get an appointment of a doctor, so during this 1 month without getting the antibiotic, uh, patient has to wait. Where a simple AI system can identify whether this problem is due to pneumonia or the patient is having tuberculosis. So readily, immediately after the X-ray is done, the patient has the initial impression. Obviously, it will not be 100% correct. The medical consultation is always required. But with 98%, 99% accuracy, the if the X-ray machine can tell you, okay, most likely you are suffering from pneumonia, to go to a doctor immediately. So the patient will not wait for 1 month to get a doctor appointment in that at his convenience. So he will make it inconvenient. You go to some place with train or bus and then visit a doctor within 1 day or 2 days. So the life can be saved. So these things can be done. But in the others, if these facilities are not available in the local center, that is why I have kept it others. Lots of research is going on there in this field. But since this topic is on AI for rural development, in remote location, we generally do not have MRI and CT scan machine. And again, if we have MRI machine, we can also have a doctor there. So that assistance is important, but in our case, that is not applicable directly. But you need to know that brain tumor, stroke detection from CT scan and MRI images, that is also possible with use of deep learning, and polyp detection and gastric ulcer the tumor in colonoscopy and endoscopy. These are all happening these days. These are not in research papers and thesis. These are all happening right now. So what is this all about? What is CNN? CNN is convolutional neural network. What is convolution operation? I will show you with the animation. What is actually convolution operation? So before I show you that to you, just tell you, if you have an image and I want you to understand what is that image. So what human can do, human can see the image in an abstract way from the top view, the overall, and then take a decision. But if a computer system need to understand what this image is all about, it can have different it will look in close in the different segments of the image. We call it features. So identifying the features is the main thing. So if the features of the image is like uh, whether the face is if a boy or girl, so it will take the area around mustache and beard. If something black pixels happening there in the area of mustache and beard, so that we call the feature. If this feature is present in one image, 100% that is male. If it is not present, we cannot say in 100% that is male or female. 50% chance of male, 50% chance of female. So this way it decides. It breaks the pictures into different segments. We call it features, and then sub features are extracted from these segments. Again, from that extracted features, sub features are extracted. This way it works. Let me show you some. So if you have lots of pictures of bikes and cars and thousands of such pictures, you have built a machine learning
Can
model.
you show the previous slide, sir?
Yes. Any question from here?
No, sir. No.
Okay. So the idea is that I show a machine that this is a bike and this is a car. Now, after showing 1000 of such images, I will show a new image which is not shown previously to the machine and ask the machine, tell me this one is a bike or a car. Say if your accuracy is say 99%, it can say the 99% correctly that which one is a bike and which one is a car. How can they do that? Because while we are showing the sample images, what the machine was doing is that machine was looking at different areas of the image, which is known as feature, like uh, the wheel, the light, the headlight, the spikes, and the seat, or like this. So there are different segment, which these segments are known as the feature of the bike. These are present in bikes only, not in the car. So this feature extraction can be done manually in conventional machine learning algorithm. Here you see, sorry, this one, you see, there is a bone image X-ray that has a bone tumor which could be malignant inside. So if we show this image to a machine, the machine will extract this type of features from this type of images. And that from these features, they learn to decide whether this tumor inside the bone is malignant or benign. So this type of features can be algorithmically developed using these are known feature extraction algorithms. This is Canny algorithm. This is Period algorithm. This is Sobel algorithm. These are very common in image processing. So you can run this algorithm to these images to extract features. Then you show these extracted features to a machine learning algorithm like random forest or support vector machine, and it will decide whether this is a malignancy or a benign tumor. But in deep learning, the convolution operation actually automatically extract the features. Can you see the simple convolution operation? Let me explain this in detail. The left hand side is, you can consider as an image. An image is nothing but a, say this image is of 5 by 5 size. So 5 row and 5 columns are there. The cell values represent the intensity. Suppose this image is black and white and the cell's intensity are numbers. In reality, the numbers comes between 0 to 255. For example purpose, we have kept it between say -10 to +10 or something. Then we have a filter. The second image is of a filter. These filter values we need to learn, because what are the filter? The filter are something that when we overlap in the image, it extract features. In the previous, you see, this is the output and this is the input. So what may have transformed this input into this output, that is known as a filter. But that filter is manually created using this algorithm. But in deep learning, we do not manually create this filter. This is the filter, but we do not create this filter. We let the system learn this filter automatically. This type of filter is known as kernel. This is known as convolution operation. This operation is known as convolution operation. What is convolution operation? You see here, this filter is placed and getting shifted, and every time the cell values of the filter is getting multiplied with the cell values of the input image, and the summed up score is stored in a output image. You see it? So the output image value, you can consider this first cell value, consider the -29 is a aggregated featured value of the first 9 cells of this image. You understood? This way the features are extracted. Now, this kernel values, we do not fix it. We let the system learn it. So this is known as convolution operation. Now, each convolution operation results in a feature set. How the features would look like. Now, every step you see, the initial image, input image was 5 by 5, but the output image is of 3 by 3. So after applying convolution operation, the image shrinks in size, it reduced in size, but it aggregates the values of the nearby pixels. So that we consider as a feature. This is the formula that we use for convolution operation output size. You see, if the input size is 32, the output size is be 16. It is half of the size. There are several convolution neural network architecture that is being used. You see, the input images is of a brain MRI where there is a tumor. You can easily see the tumor is here. The brain MRI tumor is, these are the features. These are the features extracted by convolution operation. So there are multiple blocks of such features, and this second level of features are extracted from the first level of features. The third level of features are extracted from the second level of features. This way, we go up to say 1, 2, 3, 4, 5, 6 levels, and then we add a neural network after it to identify whether that is a tumor or infection or normal thing. So you see, the output always comes in probabilities. That means it adds up to 1. So there is a 95% chance that it is a tumor, there is a 3% chance that it is an infection, and there is a 2% chance that everything is normal. So AI and machine learning models never tells with certainty that there is a tumor, this is a cancer, but there is no cancer. Or everything in probabilistic view. So if the probability is bigger than a threshold, you can decide. So ultimately, the expert has to decide. The AI system will only suggest that there is a 95% chance that this MRI scan is having a tumor. Now, there are 5 layers. In reality, what people are practicing these days, there are many deep learning models that uses more than 5 layers. This is a favorite machine learning models for AI developers, which is known as BGG16, that has 16 layers. This is the initial. You see, from the initial layers to later layers, the size of the output is always getting reduced. So, because features are extracted in a more dense way, more concatenated way, the initial features are more generic feature. The later layer features are more abstract features. This is another model known as DenseNet. The difference is that this is a feed-forward network. That means the output of the previous layer is fed to the input to the next layer. So this is a linear structure, and here it is a skip jump structure. That means the connection are having skip connection. That means it is following a linear nature, as well as the first layer is connected to third layer, skipping the second layer. The second layer is connected to fourth layer, skipping the third layer. This way, it follows both the features, the feed forward features as well as the skip connection. Somebody needs to be mute. Yes. So this is the most famous one. This is the model created by Google, known as Inception version 3 model. All this, there's whatever you are seeing in applications of automatic identification of images, like in Facebook, in Google, you search for an image, what is the content inside the image. These days model can understand. Mostly they are using this Inception Bayesian models. Medical field, the features, you see the feature maps, how they look like. In the left hand side, for explanation purpose, how the features are extracted by these layers, I have shown a cat image. You see the cat image features at different layers. Some filter is catching the eyes, some the mustache, some the nose part, some this ear part. Okay, and finally the model has learned it that this is the feature of a cat. And you see the initial layer features are understandable. The teeny little components of the images are known as feature. But this is the first level, this is the second level. As we go by third layer, fourth layer, you can hardly understand what exactly the feature is. You can see in a matrix that some of the cells are having some value, some of the cells don't have any value. The black regions don't have any value, the yellow regions and green regions are having some values. But a computer, these last layers are more meaningful than these first layers. So the more deep the network is, the better result it provides. For human being, the initial layers are more understandable. So seeing this, you can understand, oh, this is what the machine is looking at, the eyes, the mustache, the ears. Then they take decision of this, whether it is a cat or dog. But in reality, computers, if take decision on these two layers only, it will hardly get 50 or 60% accuracy. But if you give this more dense representation of features, you see, human cannot understand anything at this level, last level, but computer will understand this and they will give 90%, 96% accuracy. This is the actual medical case history. The features look like this, nothing understandable. So most of the time, deep learning is non-explainable. What is actually going on, how the computer is understanding the features, it yet to be understood by human being. But somehow we cannot prove it that it is correct, but the result shows that it is learning correctly. And there is a new branch of AI is quickly developing, which deals with the counterpart, which is explainable AI, that always explain what is happening. But this example, the features that are meaningful to computer is actually not meaningful to human being. You can see that these are the images of X-ray of, say, for pneumonia. I think this is pneumonia, the hazy part of the lungs. And the features that is useful for a computer is this. So, what do you understand? If I give you this image, you will hardly understand anything. But luckily, if you give this to a model like Inception, this, you give these features here, it will say, well, okay, this person has pneumonia. Another important part is image segmentation. Segmentation is that we can, if we remove the background from the image, it is very easy for the computer system to understand what is going on. So suppose we want to say whether the lungs is hazy or not, the lung size is reduced or not. You see this if we can remove the bones, the fluids, the tissues, the cells, just the lungs only, then it is very easy for the computer to understand, well, okay, the first one is the one that is having the abnormality, because the left lung is very small in size. That means the rest of the part of the lungs is either filled with fluid or any tumor. So there is something definitely wrong with this. How we can do this? Similar type of architecture, convolution architecture known as UNet. This looks like U because the initial layers are very dense. Then we have a smaller layer. Then again we this is known as convolution. The first part. The second part is deconvolution. Does the opposite thing, and ultimately the image is getting segmented. So this is another type of imaging issues that we can do in automatic image analysis. Now, saying all this, is it very easy to implement in home system? Actually not. Actually not. You can see the comparison of the models. It is chronologically listed. That means the very beginning of machine learning starts with LeNet and AlexNet, then come VGG, then come ResNet, then came Inception, and these last two are the most recent versions. So how many layers we have? This is the largest model, Inception, DenseNet. They have this larger type of layers number, and the number of parameters that need to be trained are on millions. So this much million numbers. And the time it takes is counted in GFLOPS, maybe gigaflops. Flops means floating point operation per second. Floating point operation means it will be able to add, multiply floating points. So how many floating point operation one computer can perform in 1 second, known as flop. So if 1,000 of that type of operation is performed in 1 second, that is known as gigaflops. So gigaflops actually measures the complexity of the system. So what has happened these days is that these models are not compatible with low resource computers. It requires GPU. We may have heard GPU, graphical processing unit, these days are required for. So they're very expensive computers. But last two models, you see the mobile net and efficient net, these are discovered hardly 5 years ago. They have the least amount of G-flops, as well as the number of parameters is very less with respect to others. So these two models actually, mobile net, as the name suggests, this is a deep learning network that is meant to be run on mobile devices. So if you run this type of model in mobile devices, you can have a preliminary understanding of your imaging reports at your home. But what are the challenges that we face? Yes. The first challenge is the ethical issue, that is data privacy and security. For machine learning model, you need to collect all the images in one place to learn to train the machine learning model. But the hospitals, data centers, they do not want to share their information about patient imaging. Okay, there is a privacy and security issue and ethical issue also. There are standards globally set by government organization that which type of information could be shared across hospital and which cannot be. Data quality, different imaging modality uses different resolution. So data are of different sizes. Okay. Data heterogeneity. Heterogeneity means different version of data can be available. Like file could be in JPEG format, in could be PNG format or different formats. Bias in data set, that means patient information in one data center could be say 90% of the patient are male, only 10% are female. In another center, it could be like that. 80% of the patients are elderly. That means 60 years and above. Only 30% of the young patients data is available. So there can be always biasness in the data set. And device compatibility, I told you, even if mobile net and efficient net learn on edge device like mobile phone and cameras, uh, model to model, builder, maker to maker, it varies. So not it is that easy that you have an algorithm, you install it in your mobile phone and it will run ready. It is not as simple as that. So these are the key challenges. How do we handle this? We have a solution that covers most of this, is known as federated learning. This is how this algorithm works. What happens in a nutshell is that the edge layer, the data you need to never share your data to other hospital. Your local center will have a edge device and it will train the local data here. So nobody is sharing this data, but individual machine learning models are trained individually at the local center. Now, while learning, what they do actually learn, they learn the weight of the matrices. Now, this weight of the matrices that are encrypted, that doesn't reveal any information. These are only numbers that I showed you in the convolution image picture. The numbers of the pixels, that doesn't mean anything. That they share to the cloud platform, and then they aggregate based on the participation. So that biasness will be gone, because if suppose this weight is 10, this weight is 12, this weight is 5, this weight is 8, this weight is, it is not a simple averaging of the weights. The weight averaging will be done based on the participation. That means if you have total 100 data and 70% of data coming from this particular node, so that weightage will be given preference. So nk by n is the total number of participants and nk is the number of participants coming from the kth client. So if this data center having the majority share of the patient information. So that weight will be given preference like this. So this is how federated learning overcome many issues, like the biasness will be gone, the privacy issues will be gone. You need not to share your information with anybody. You share only the weight of learning, and the security is also there. Nobody can, no intruder can come and collect the information because the actual imaging information is not being shared. The heterogeneity will be to some extent mitigated because we are averaging different clients or different data center will be using their different application like mobile phones, CC camera, or the imaging devices of different modalities. But after aggregating, the average will come out. So this is how federated learning handles these issues. And the final one is that what is the future from here? The future seems to be promising with this roboted assisted surgery, where you have heard this, that it is yet to be implemented. It is in lab stage in very research laboratories and hospitals. People are carrying out robotic assisted surgery. In implantable neuroprosthetic, again, prosthetic is okay, but if that prosthetic is to can be controlled remotely, that will come a big ethical issue. That using remotely controllable prosthetics will make you a robot, can make you a robot which can be controlled by somebody else, because without the full control of your prosthetic arm or leg, you can be controlled by any other person who is having the connection with the prosthetic. So lots of ethical issues, but the future directives are there. These are the research areas that people are working on. Ingestible microbioelectric device. These are devices like capsules. Will have the chip that you will take with water, and it will go to your gut, and it will take picture and sensory images of the entire passage of your gut, of the intestine and the stomach, whatever the path you follow, the capsule will follow, and ultimately it will be disposed. So if, during the process, it will take valuable information about how many count of good bacteria, whether there is a blockage or not, whether there is a thinning of wall lining, or there is ulcer or not. That everything can be taken care. And finally, I told you personalized medicine is a big issue, that instead of giving same medicine to same everybody on the same disease, it could be better if we can create new drugs based on the genomic sequence of the people. So that is known as personalized medicine. But that is not a near future. That will take time, but people are working on it. So this way we can mitigate the problem of rural healthcare to some extent that I initially stated. These are the references I have used for this presentation. And any questions?
Thank you, Dr. Thobi.
Thank you.
Yeah.
Thank you, doctor.
If anybody having any question, somebody have raised a hand. If you have any question, you can ask this.
Yes. Okay, I'm seeing Priyanka Tendulkar about bone fracture. If AI application is provided with reference images about fracture, can it ascertain whether the bone has healed or not? Yes. That I told you, that is not that easy, because that is a temporal problem. You have to suppose you have two consecutive images, not only bone fracturing. Suppose a wound healing image. So that is a temporal. That is a series of images you need to collect. So that machine learning can learn a system if proper samples are provided. The proper sampling is very hard to find out because suppose how many intermediate images we have till now? Nothing. What we have in the health center is that the initial wound image and the final healed image. But if you want to train a machine learning model to see if the progress is going correctly or not, you need to have the intermediate images. So that system has not been practiced till now. But luckily, people are taking pictures these days. Whenever you are going for a wound injury recovery, every time you are visiting doctors, doctors are taking images, intermediate. If that electronic health record is kept properly, yes, we can train a machine learning model to identify if the healing process is going correct or not. Okay. Any other question? Please share the PPT presentation. Surely I can do that. I can send it in the mail to the organizer and they will send it to you.
Thank you, Dr. Sobik. And I talked to Abhishek also in this regard that you can also develop it in a paper mode so that we can come out because this is a very interesting topic and overall in our program schedule we have covered different aspects of rural development and agriculture, how AI can do. So at least our speakers can contribute and it may be helpful to as a documentation, not only the PowerPoint presentation and other, to become as a good paper. So we'll work on that. But overall, this is very important. The rural healthcare management, and particularly during COVID situation, we have faced a lot. And after that, how AI can help us and doing help, not only help us, but it is already doing.
Yes,
Even small thing is the even our personal things also. Now, if we can put in the proper, even a simple chat GPT also a little bit helping what to get and this, what is the use. So wherever I am taking any medicine, first I used to give it to the chat GPT and I am getting a lot of things from that and the pros and cons, whether we should use or not. So those small things, not in that methodically as you mentioned, not that way because this is neither our domain on this, but this presentation was awesome and a lot of things are there and a lot of people are talking and which is going to be a big challenge as a big data management and when data means all of us is a data. So and
we are working
everybody
on
having,
data these days. Yeah,
yeah, all of us are data and having a lot of medical tests and these. So that is again number of multiple data. So how to analysis those things and how to come out with accurate uh, uh, management. Even it can help a lot because there are a lot of doctors sometimes the facilities are not available in the rural areas.
exactly.
This, yeah,
It is
these
it is
tools.
right now taking place, but in the advanced cities, only in the smart way. But
Yes,
the rural development is the biggest challenge.
exactly. So it's all about application, but how you are doing. Tools are available, but application things are important. But I'm quite sure that the even general physicians they are also using those tools. Even a lot of because mobile is there, so slowly getting some momentum in the field of rural health sector also in different way. May not be today, but as you have made a futuristic presentation, maybe in the coming future AI is going to make a big deal with this as is already started in the education sector. All our student universities teachers we are using, everybody is using. Now it's a problem how to stop that. How to
Mhm.
stop that is a big issue. Even earlier, when we did our PhD, that time there was no source. Now this is the problem, that data available in the Google. If you give any topic, so many articles are coming. Now it is a big problem.
No,
Having
you cannot
information.
stop it. Once technology arrives, you cannot stop it. You need to
Exactly.
control it. Every
Exactly.
technology has pros and cons. You need to control it for the betterment.
Yes, yes. And it has obviously, every technology has, it is a positive thing as well as is a loopholes also there. But the best thing is how popular the presentation. And now from India, I have to go to that our another speaker from Turkey. She is there, Professor Gulsan. Professor Gulsan, are you there?
Yes, I
Okay,
am
so
here.
okay,
Okay,
yes, sir.
okay. So
So I'm leaving now.
yeah, yeah. So if you are living, and Professor Gulsan was, listening your presentation too, and
Okay, so
and
nice.
we started the entire program with the first presentation with Professor Gulsan, from that introduction how AI can help. And in the, today is the last presentation, and we can't ignore, when there is a rural development, we can't ignore the women also. Not only speakers, but how the women can help. The AI can help in the women empowerment, gender equality, many more experiment going on, innovation is going on, and Professor Gulson is going to talk on that. So once again, thanks to Dr. Sobi, and we'll be happy if you can also listen to that, the next last presentation, how AI can help, and together, because all of you are our team. Though Abhishek is leading in this sector, but all your supports are required to develop this sector, how AI can help through our forum in the rural development. So with this, I am switching to Professor Dr. Gulsan. Please.
Hello from Turkey and good night, good evening to everyone. Again, it is my honor to be with you. I am so excited. I learned a lot from you, and also thank you, doctor. Using AI in medicine is very important. Just I read they developed a new machine to the AI-based machine. It can easily read what is going on in our inside, kind of MR machine. So it is very important. So today I try to upload my, yes. I think I can right now. Hopefully you can see my presentation.
Okay, today is not missing. Welcome, Prof.
Hello. Hope everything is okay with you all. I try to, yes. Today we are going to talk about artificial intelligence and rural women and their empowerment. I especially focus on Turkey case, how we use artificial intelligence at the rural area for women. So I'm telling it, we're driving innovation for tomorrow. And yes, honey, it is my presentation. You have to sleep. My kitty cat is here. I am so sorry, I try to, how can I, okay, I try to move my presentation. Hold on. I'm so sorry about, I am not use the Google one. I must, it is my excuse trying to find, this is the PowerPoint one, okay. I'm trying to open the PowerPoint one. I convert the PowerPoint, not to PDF. Okay, teaching women is very important. Oops, honey. Hope you can see. Yes. Yes. If I can move it, I can show all the presentation, but I couldn't succeed it. I am so sorry about that. Okay, let me talk about, and you can, but it doesn't work at my computer. I don't know why. Okay, I have a motto here. Maybe you can see. My motto is.
Sorry, try to click on the slide, the number 2. Try to click it on it. Maybe it will work.
I do that, but it didn't move.
Didn't move.
I tried to. It doesn't do anything. Hold on. Yes, this is the PowerPoint one. Yes, I said share. And I tried to, I saw it, but I cannot do anything on it. This is, I don't know why. Just trying to upload right now. I am so sorry about that. Yes, I am seeing my presentation, but cannot do anything. I don't know why. I am so sorry. Hold on, one more thing. I try to. Yes, last day, last moments, we have problem, Houston, because of me. Can I see this one? Now, can you see it, my presentation? Can you see it?
No, ma'am.
No. Okay, it
Yes,
doesn't
yes,
work.
yes.
Came up just now.
Ma'am.
It just came up.
That's correct. Yes. Let's
Yeah.
talk about artificial intelligence and rural women empowerment.
No. Yeah. We can see it now. We can see
Okay.
it now.
Thank you, thank you, thank you, thank you. And also, I try to focus on Turkish case because women are always important in Turkey, especially rural area women, because it is the key issue if you would like to develop. Being a developed country, you must first educate your women and support them. So let's see. Our motto is empowering rural women through artificial intelligence, bridging gaps, initiating futures. It is very important. This motto is very important for us because we are highlighted empowerment by focusing on women. Empowerment of rural women recognize their vital role in our communities in Turkey and also all our communities. Empowerment leads to increase autonomy, self-esteem and decision making. It is very important. And we also addressing inequities. There are a huge gaps between men and women, especially at the rural areas in Turkey. So because they always or most of time face numerous barriers, including limited access to education, healthcare, and economic opportunities. So we would like to focus on how can we break this gap. So also we are emphasizing innovation. What is the role of artificial intelligence? This is a transformative and it is a transformative potential for women in rural areas, especially how we can educate, how we can provide healthcare issues for them, how can we provide economic issues, how can we hear their voices. They don't feel alone. And fostering a future growth, it is very important, the future. This phrase reflects the idea of new opportunities and possibilities for women in rural areas. So I can help us to support those kind of women, and creating awareness is another important issues by inspiring action. The words are uses if you are not turning your words in action, and artificial intelligence help us. How can we turn our words, our plans, our strategic improvements in action? So today we are going to talk about those issues, and in especially Turkish case. So we have to understand rural women's role. We have to appreciate. If you look at the developing or underdeveloped countries, women are most of time kind of the disadvantages group. They are in a disadvantages group, especially for education. In Turkey, let's say if a family has 7 or 8 children, and they let the boys go to the school, and they prefer women stay at home, help mother, and they get married as soon as possible. So we try to educate them. Woman is the most important. If you educate your woman, especially in rural areas, you educate all over the country. So harnessing opportunities, challenging cybersecurity, machine learning, consulting are the 5 important issues for us. Why they are important? Without providing cybersecurity issue to your woman, you cannot do anything. The woman, some level, must learn machine learning, deep learning, and also we have to provide, and we have that kind of issues, consulting, distance, online consulting via artificial intelligence. So provide several opportunities by overcoming challenges, and harnessing is very important. So artificial intelligence technologies can ensure how we successfully implement in our rural area women education or women life. Why empower rural women? Yes, it is very important for we try to get benefits for their families, their communities, and economics when women are empowered. So again, you have to understand and ask your question. We start with this question: what are the roles they have, the woman in your rural area? They have to cook, they have to go to the land, get some stuff, or get ready for the animals, I don't know, or all. You have to understand and define what is your contextual background, first of all. Then how you try benefits for them via artificial intelligence, and then you can create custom approaches for each area, because each area has own taste, own needs, own expectation for future. So you cannot use the same programs, you cannot use the same understanding approaches to everyone in the rural areas. You have to customize your artificial intelligence based approaches. So you have to find grant, and because this is technology trends, you have to get support from your government, local and big government, and you have to start to thinking how we can solve the problems even before they occur. We call this intelligence, smart intelligence for women. So they have to understand how can cope with the problems. I always say it is a tool. Without getting enough information, enough education, enough knowledge, enough voice for women, they cannot ask right questions to make right decisions. So to make everyone, especially women in rural areas, smart, we have to provide them all solutions. This is how we approach the AI at a macro level. Yes. Then we think about artificial intelligence integration. So which AI tools, how many people, how they get affected, how they utilize them. So this is a kind of edge computing area. We have to try to bridging data processing issues closer to our source, to the woman. And blockchain, another issue, decentralized communication, decentralized marketing. So we are trying to transform the data security and transparency by using blockchain in rural areas. And another issue, quantum computing. It is getting better and better. This is a next level processing power for complex problems. It means we can solve the problems in a short time, but the problem is right now quantum computing needs a cool areas, making if we would like to work it very powerfully, it must be cool. But we start to think about how we use quantum computing and make a network among the rural areas women, so empower their solutions. So this is another issue in Turkey. Yes, access to information is very important. Several application in the field, like how can you do farming, crop monitoring. It is up to you. So how they our women use, and in Turkey most of them using for their farming, for animals and crop, and the weather and market issues are very important here. So you have to teach them, your woman, for artificial intelligence, what we are doing here right now in Turkey, how they solve their financial issues, how they develop their skills, how they keep themselves their well-being high, socially, psychologically, physically, and how they build artificial intelligence for social interactions, for economic opportunities. So those four issues are very important when we talking about artificial intelligence in Turkey for rural women support. So you have to decide which one is, or maybe all of them are very important to you. So you have to make choices, opportunities to create them for women. And you have to train your woman by artificial intelligence for artificial intelligence. They have to know how they use. Yes, there are several success stories all over the world, like Digital Green India, M-Pesa in Kenya, AgroStore, you name it. When we look at like Turkey, women's success in rural areas, those stories highlight real dramatic transformative results like cost reduction, enhanced cybersecurity, productivity boosts, technology implementation, lifelong learning, digital literacy, and you name it. To me, lifelong learning is the key issue if you would like to get successful in rural areas, not only women, but also for children, for men. And you have to provide education, training issues seamlessly. Yes. What we are doing, we have a strategies for implementation artificial intelligence. Again, to empower women through education and training, we are producing programs and partnerships to promote their digital literacy and artificial expertise. with universities, NGOs, and getting grants from the European Unions. So continuous, seamless learning environments we try to provide them. The role of governments, NGOs, and private sectors are very important. You must collaborate with them because they have to understand why this is important. Because we have to foster ecosystem. Without our ecosystem, we are useless. No rural area, no urban areas. So we have to support our ecosystem also by using artificial intelligence. Another in Turkey, equity and inclusion in artificial intelligence development. So we have policies, practices, and we consider the specific needs rural women. Each rural woman can different ideas, different needs, different expectation. We are conduct several researches on it to answer their needs. And call to action, action, another key issue. You have to encourage your stakeholders. They have to invest artificial intelligence initiatives, and this provides rural women opportunities to use them, utilize them in their area. Okay, if you look at what kind of tools we have, most of them we are using in here, like Socrates, Digital Greens, Kiva, you name it. I'm not reading, like IBM, Health, Benevolent, Farm Drive, Hello Tractor, and also we have agriculture colleges and also computer colleges, engineering colleges. They are working together to produce our own artificial intelligence programs for women in rural areas, because if you use just the products from the outside the world, it means we can transfer their culture and their stereotypes. I just read again, they found high stereotypes in artificial intelligence for Black women. The artificial intelligence face recognition programs cannot perfectly understand or define Black woman face. So it is very important. It means it is a stereotypes. To break it, you have to develop your own. And see, in this year, if you look at what would you like to do, you can use several tools like writing, Twitter tools, social media. You must market your products. You must use social media, and those tools are very powerful. And also like Meta AI, Google Image F, Microsoft Designer, Napkin AI, they are free. You can use those ones to help you. And also, you know, the most famous one, ChatGPT. I get these prompts from the ChatGPT site. It is not, they are not my prompts. You can use ChatGPT freely. It helps you. You don't need to purchase. It gives limited access, but help you. You can use those kind of prompts, like, you know, use visualization, you know, convert this prompt to your need. But the best thing, you have to use your own language perfectly. Most of area in rural areas in Turkey, women cannot speak English so we are providing that kind of tools for them, the people also. But I think in the part of the East world, people can speak English better than Turkish ones, because English is, I think, your native language in most of area. So use your language wisely, define it, not use your language like texting in social media, and explain it. And it helps you, ChatGPT, like, you know, the mastering a hobby, you can change this one. How can you grow your crop? Excuse me. How can you analyze your case? You know, those prompts are very important, and it helps. How can you develop your own prompt? And also you can implement your writing system using ChatGPT. See, there are several of things. If you would like to do, how would you like to learn a system? How you learn a technique? You can use this. Yes, the future is here right now. So we have to understand how can we own our artificial intelligence tools for rural women. We have to conduct foresight studies to predictions to plan our future now. Otherwise, we missed our future. So it is very important because when you provide artificial intelligence to your woman, you have them how can be creative and understand their value. It means we have the economic background and we have do tons of research, and all events, all action must be rural woman centric. So it means social and collaborative issues are very important in local and global ways. So the issue is, yes, artificial intelligence will evolve us, will evolve rural women's empowerment, but we have to manage everything right now, doing conduct several research and research-based actions. Otherwise, we cannot be successful. What we are doing in Turkey, yes, we are using several grants from Turkish government and also European Union's friend of mine nowadays are using artificial intelligence tools to teach women how they make crop without, using land. And this is another issue. So there are several things, but you have to look at your future from now by using research. Those research can be developed by artificial intelligence, had by artificial intelligence, but you have to engage your woman in your future. Otherwise, you cannot be successful. Thank you. If you have any questions, you are welcome. I am so sorry. I am so sorry. Thank you for listening to me.
Thank you, Madam, for the nice presentation.
Yes, I I did send. Welcome. And hope we can find all solution for us in rural area, not just only women, for men and children, elders, or other disadvantages group, because the development must start in the rural areas. Otherwise, we cannot be successful. Our rural areas are future. We have to understand that. In Turkey Republic, when Atatürk established, he started the empowerment, development in the rural areas. So this is why Turkey is getting more powerful in this area. This is our motto: get educate rural area, get development. thank you for listening to me. Hope we can meet in person. Sure, I will. The woman in the cities, yes. In rural areas, some. But if you're going to the very small rural areas or in the middle of Turkey or east part of Turkey, very rare. Because our mother tongue is Turkish, most of places. English is not our mother tongue or second language. But thank you to social media and mobile phone, especially children can easily learn English and also other languages by playing games. So we will see. Thank you. Stay safe and see you soon in person, hopefully, in Turkey. I think there is no question. I cannot see. Yes. Thank you. Thank you all giving this opportunity to me. And I am very happy to be with you. I'll again learn several things, new things. And you know what? I changed my research focus also rural area more right now. We have been writing a paper and trying to getting a grant from European Union. We will see. Okay. See you soon. Stay safe. Yes.
Okay, thank you, Prof. Thank you for this presentation. Because I'm interested, I'm a woman and I'm in gender-related studies. I want to thank you for this presentation on AI and women empowerment. I have seen some other places, some other examples that you have given where this AI can be used for empowering women, especially the rural women. I am so glad, and I think I will start doing something in that direction in order to, even if it means creating awareness on how to have a seamless, especially for agripreneurship for women. Mm. For women, yes, in my area. I am joining from Nigeria, especially the southeast Nigeria, so that I can also tell the women more on AI so that they can have a seamless production, especially in agricultural sector. Thank you very much for this presentation.
And also still I am in favor of radio. Radio is very easy. It's if you use radio and artificial intelligence program together, you can easily reach. It is, you know, that you have to spend less money. Radio also help. Okay, and another issue.
Yeah. Okay. Thank you very much.
Thank you. Yes. Okay. I am checking it out. Oh. Thank you. hope we will be successful. The important things, we have to put our heart to this education in rural area, and we will be successful because we are the smart people and our intention is very positive and helpful. And I am very thankful to being that kind of among that kind of people. Thank you, and see you soon. If you have no another question or any suggestion, any feedback, say good night, and hopefully you can visit Turkey and we can meet in person. Bye bye.
Thank you, ma'am.
Thank you, ma'am. Thank you so much.